WBU Institute. Today we are going to learn about Now when an alternating current is applied to the primary side, this alternating current is transferred to the R1 and X1. Thus it is transmitted to the parallel resistor and inductor, which is denoted as IW, which is called as a leakage current associated with a leakage flux. Later I'll explain what exactly a leakage flux is. This is just imagine IW is a leakage current which is associated with leakage flux, and IM, which is called as a magnetizing current. So here we can develop an equation called I naught is equal to IW plus IM. I naught is nothing but the no load current. Now this is transmitted to this will generate a magnetic flux of phi. This will generate a magnetic flux of phi. In order to that, an EMF is generated in both primary and secondary area, that is denoted as E1 and E2. Got it? Here the magnetic, already I told you that leakage flux, it is nothing but a flux which is generated which links any one side of a transformer. Any one leg or any one side of a transformer. Leakage flux is a flux which links any one side of a transformer. Now, and current flows in the secondary coil through R2 and X2 over the load. Now, it generates a magnetic flux with respect to that of a EMF generator over here, which is denoted as phi dash. The generated phi dash is always opposes the phi which is generated by the primary side, means that it depolarizes. Just imagine the equation here. In the primary side, V1 is always greater than E1, whereas in the secondary side, E2 is always greater than V2. Means that in this area where the current applied, the electrical current, EC current applied is always greater than the EMF which is generated, but here the EMF generated is higher when compared to that of a V2. Because of that, the flux generated in the secondary area is higher when compared to that of a magnetic flux which is generated in the primary area. This opposing will make a larger potential difference between the alternating current, that is V1 and E1. Since this phi 2 decreases or depolarizes phi, because of this the E2 is get reduced when compared to that of a V1. There will be a larger potential difference. In order to tally this, what we are going to do is that we are going to transmit a reflected AC current, that is I2 dash, where I2 dash can be denoted as K into I2, where K is a transformer potential and I2 is an reflected current. Now I2 dash is transmitted over the primary circuit, which will increase the E2, whereas with respect to that of a phi is get increased and kept constant. Because of that, the transmission from the primary circuit is transmitted to the secondary circuit, that is AC current is transmitted from the primary circuit to that of a secondary circuit. Now with this, the circuit diagram, equivalent circuit have been ended. Now we'll write some of the equation with respect to the primary side as well as the secondary side. So in the primary side, we can write the equation as V1 is equal to E1 plus I1 in the multiplication of R1 plus J into X1. Whereas in the secondary side, we can write the equation as E2 is equal to V2 plus I2 in the multiplication of R2 plus J into X2. This can be rewritten as V2 is equal to E2 minus I2 in the multiplication of R2 plus J into X2. These are the major equations. Nearly 4 to 5 equations have been discussed in this session. This will be the base for the phasor diagram. With respect to this, we'll draw a phasor diagram.